think I should go with, otherwise it will not have enough time. Okay, ready? Ready. Okay, so the first one says we have a spinner can land on 3 numbers, 1, 2, 3. Each of these outcomes is equally likely. It says if the spinner is spun twice and the sum of the 2 spins is recorded, what is the sample space? Okay, so as I said, it's like you have 2 dice, and each of these has 3 faces, and you roll both of them together, and then you are going to write down all the combination of these 2 faces, right? So the first column, let's say first spin, and then this is the second one. Okay, so the first one can show 1, this one 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. How many outcomes? 9 outcomes. And then now, because they asked us to add these 2 numbers and write down the outcome, we should write down summation 2, summation 3, 4, 3, 4, 5, 4, 5, 6. So if I want to write down this summation as a sample space, I have all the numbers from 2 to 6 and no repetitive number, right? But this is the sample space you need to find a probability, right? Correct? So those 9 outcomes are the most important one that you can find a probability from. It says, what is the probability that the sum will be 4? So we have this situation, means this outcome, right? 1, 3 gives us 4. And then we have 2, 2, this outcome, 3, 1, right? So I will write this down as a event. Event A is 1, 3, 2, 2, 3, 1, right? And then we have 3 outcomes here. The probability of observing A is 3 over louder, 9, right? So 1 over 3 is the probability of observing A. Do you remember this from chapter 12? So that's good, we have a review, because this will be a question in exam. So you should review all of this, right? We had many questions like that, chapter 12. So now it says, let's A be the event. The first spin is 1. Okay, we have A here. The first spin 1 means all these outcomes, right? So 1, 1, 1, 2, 1, 3, because all of these are showing 1 on the first spin, right? So 1, 1, 1, 2, 1, 3. And then it says now B is the event, the second spin is even number. Okay. Which one? 2, 1. The second spin is even number. 1 is not even number. It should be 2, 4. 2, 4. Sorry. 2. Just 2 on the second one, right? So what is that? 1, 2, 2, 2, 3, 2. Exactly. Correct?
Yes.
Okay. So 3, 2, 2, 2, 1, 2. Okay. Correct? Because these all have even number on the second die. Right? So now, is there any common outcome between A and B? What is that? 1, 2. So are they disjoint or not disjoint?
Not disjoint.
They are not disjoint because they have exactly a common outcome, which is 1, 2, right? That's it. Do you have any question? So the next question says human blood is grouped into 4 types: O, A, B, AB, and then they say the following table lists the probability of this blood type for a randomly selected American. The table has missing values for probabilities blood A, B, and AB. A single person is to be drawn at random. The probability of drawing an American with blood type O or A is, okay, let's write down the information they are giving us. So we have probability of blood type O or A to be 0.85. Then it says, and the probability of not drawing an American with blood type B is 0.88. So if we say we are not observing something, the probability of not observing something according to the probability rule is 1 minus probability of observing that, right? So we should write down probability of not observing B is 0.88. Okay, so probability of O also is 0.44, right? So let's start from maybe this one, because I just talked about this. So probability of not observing B is 1 minus probability of observing B, right? So this one is 0.88 is equal to 1 minus probability of B, which is unknown. So what is the probability of observing B? 0.12. Correct?
Yes.
This one says probability of O or A. We know that if 2 outcomes are disjoint, so blood types are disjoint. So we can write down probability of O or A is equal to the probability of O plus probability of A. Then this one is 0.85 equal to, we have probability blood type O plus we don't know the probability of blood type A. So from here probability of blood type A is 0.41. So what remains? AB. So we write down the probability of A plus probability of B plus probability of O plus probability of AB is equal to 1. right? If we add all these probabilities, we should have 1, right? So this is equal to 1. We have probability A from here, 0.41. We have probability B from here, 0.12. We have probability O from here, 0.44, but we don't have probability of AB. But we know that if we add all this together, we should have 1. So probability of AB is equal to 1 minus, what happens if we add these all together? We have something 7, 97? Am I right? Okay, so we have 0.03 for probability of AB. Do you have any question? No? So, the next question. It says, suppose the number of hours per week adult in the US spent being physically active is distributed normally between 2.4 and standard deviation 0.6. So, X, one single observation, has a normal distribution with this mean, am I right? And this is standard deviation, correct? X bar, average of n, how many? In the next part it says, if you take 6 of them, right? In the part B, it says 6 of them. Average of 6 has a normal distribution, the same mean as population, but the standard deviation changes to 0.6 divided by square root of 6, right? So now, we use this one to answer part A. We use this one to answer part B, right? It says, what is the probability that a single randomly selected adult in America spent more than 3.2 hours per week being physically active? We start with x equal 3.2. Z is x minus mu divided by sigma. Because we are talking about one single individual, we have sigma. We don't have sigma over square root of n. But in this case, we will have a different standard deviation, right? So 3.2 minus 2.4 divided by 0.6 is equal to what? 1.33, correct? So now the probability of Z, they said more than, greater than 1.33. So now you know what I mean by this, means greater than, right? Yes. So this one is 1 minus probability of less than, right? Yes. 1 minus the probability of Z less than 1.33. This is less than, and you can find this from table A. Am I right? Yes. So we have 1 minus what? 0.9082. Is this correct? So what is the answer? 0.0918. 918. Can you explain this? How you explain this? So this is 9%, right? 9.18%. So now you will say there is 9.18% chance that a person, okay, in America It happens just in America. Look,
More than
they are physically active.
they spend 3.2 hours.
Only more than how many hours?
3.2 hours each week.
Each week. Imagine each week.
I thought that was
That's not a good thing.
No, I said I thought it was a good thing until I saw each.
Yeah. They
I
spend
thought each
more
day.
than 3.2 hours. 3.2 hours per week. Imagine it just happened, probably it just happened in America. Because people are more, there's more convenient way of doing work and everything, so you don't have to run every day. And you always use your car, and that's the problem, to go everywhere. So, that's sad. Oh, so the next part. Now we take average of 6 people, and we want to see what they do during week, how long they are physically active. So we have X bar equal to, what is that? Again, we are talking about 3.2 hours, right? 3.2 hours. Now Z value is X bar minus mu divided by sigma over square root of n. Am I right? 3.2 minus 2.4 divided by, what is sigma over square root of n? Do you remember? I said calculate this because I know lots of time you will have a mistake. So what is this one? 0.24.
0.24.
Okay. So 0.24. So what is the final answer for Z value?
3.27.
27. Okay. So now what is the probability that the Z is greater than 3.27, which is 1 minus probability of Z less than 3.27, and then you get this from table A is equal to 1 minus, tell me, 9995 is equal to 0.0005, almost zero. So there is 0% chance if I choose 6 of you here, you are spending more than 3 points. No, actually it refers to all the population, you know. So, and I should choose randomly. So choosing a student just from my class is not correct, right? So I should have a bigger population and choose randomly and ask them, how long a day you are walking? And then I will record all the time. So now you know what should we say. There is just 0% chance that average of 6 people in America spend more than 3.2 hours being physically active. Do you have any question? What time is it? So, next question. It says, suppose that in fact the total cholesterol level of all men aged from 20 to 34 follows a normal distribution with a mean of 182. Let's write this down. 182 and a standard deviation of 37. So now X bar will have a normal distribution. The same mean and a standard deviation will changes to 37 divided by square root of n, right? What is n? 100. Okay. So what is this number here?
Margin of error.
No. Margin of error is for chapter 16 and 17. Okay. What is this one now? Oh, actually 3.7. Yeah.
That's what
Because that was the square root of 100 is 10. And
Okay.
so now, let me see what question we have. It says choose a population. What's the sampling distribution? This is the sampling distribution. This is the part A, right? Sampling distribution of X bar has this mean and this is standard deviation. And you will write it down in this form. B says what is the probability that X bar takes a value less than 184? Okay, I'm going to use this one. X bar 184. X bar minus mu divided by sigma over square root of n. 184 minus 182 divided by 3.7 is equal to 0.054.
0.0 or
Point
not
zero,
point.
like 0.05.
0.005.
I got
It's just
I got
fine.
0.5405. 0.54. That's what I got 0.54. I don't-
0.54.
Yeah, not, there's no zero. Yeah, 0.5405.
Good?
Yeah.
Okay.
And then from Z table you get 0.705.
Oh, okay. So what it says, more than or less than? Less than. So less than 0.54. So you don't have to change it to 1 minus, right?
Yeah.
It's already the left side of the value. What is the answer?
0.754.
754.
Or 70%. 0.705.
054, which is 70.54%, right?
Yeah.
So what was that? What is the probability that X bar take? So average of 100 men will, there is a
70%.
70% chance that average of 100 men
Will have less than.
have cholesterol less than 184, right? Do you have any question? So the next question says, now let's try to see what is the probability between these two values. We already calculated X bar 184. So let's calculate X bar 180. So Z is X bar minus mu divided by sigma over square root of n. 180 minus 182 divided by 3.7 is equal to 540. 5.
Negative 0.5.
Yeah, again.
It's just
Because this is negative. So we have this. Now let me write down. Probability of Z between the smaller number is negative 0.54, right? The bigger number is 0.454. And then if we want to calculate the probability between these two, we subtract the probability of this one, a smaller one, from the bigger one, right? So from table, actually we found this. This one is 70.54 minus this one is
2946.
2540.
2946. 46.
So the bigger probability minus the smaller probability, right? 40.99%. So there is this much percent chance that if we get average of 100 men, the probability of their cholesterol is between 180 and 184. Do you have any question? So these two, both of these probabilities come from table. Let me draw a picture for you, so in case you forgot what we are doing. So this was the picture. Negative 0.54 is here. 0.54 is here. Am I right? We want the probability between these two. Means from this line to this line. We want this one, right? This is a question mark. So to find this, first we should see what is the probability all the way from here and what is this probability. This was, the bigger probability was 70.54. The smaller probability is 29.46%. So we are subtracting this area from the whole area to get the middle part, right? Any question?
It's actually 41.08.
41.08.
Yeah.
41.08. Good? Okay. Do you have any question? So, next section, which is next lecture, not lecture, next time. You have exam on Monday, right? You have exam. Bring your calculator. I will bring this table for you. You have 1 hour and 15 minutes. Be on time. As you know, you are losing your time if you are not. For extra credit, as I mentioned before, you have to take all the learning curve, finish all of them to receive 3 extra credit. Yes?
What's the snow part for this exam?
5 by 8. Is that? 5 by 8, yeah. It's, yes.
Using 8 by 8.
No, just these 4 chapters. Just 12, 15, listen. 12, 15, 16, 17. Just these chapters. Okay? And then, those who didn't ever have, what is that, absence so far? Did you sign now? Have you signed? So, if you didn't have any absence, you are going to receive 1 extra credit, and I will add that to the overall grade before I enter the letter grade to the UNM Learn. No, not UNM Learn. I mean UNM overall, UNM website. So this 1 extra credit, you will not see that in your sapling, okay? I will add it at the end when I'm, adding, entering your letter grade. And what else? Do you have any question? Any question? No? Let me see who get extra credit, so you don't bombard me with all your emails. Did I receive extra credit?
Wait, what?
Yes.
For signing
Leave
in?
me alone. So let me see you too. Be on time. Be on time. If you want to be favorite student, be on time. So there is Jennifer Garcia. You.
I missed a day?
Ben Ali. Oh, no, not Ben Ali. One miss. Sorry. Well,
Missed a day? No, I didn't.
what I said, I'm saying you get extra credit.
Oh, I thought you said I missed a day. I was like, no, I didn't.
And then Golden also. No. What? Why?